Hello everybody, my name is Chan. I'm from Cisco Networking Academy. Today we're going to talk about how we're going to do how the bridging table works, alright, in the switch. Alright, suppose the switch receives a packet. The packet will consist of source MAC address, and then you have a destination MAC address. And then there will be other information such as port number, the time it received the packet, and also the VLAN ID. Right. So when during the MAC learning process, all right, the switch will take the source MAC address and it will hash the source MAC address. You will hash it and get a hash MAC address. Let's say this is MAC 1. Okay. Then what happens is that they will take the value of the hash and they will mod it with the 1000. Okay. This 1000 is the maximum number of MAC address supported in the switch, right? We use 1000 because this one is just for an example, a simple example. In real life, for catalyst 3560, you have 12,000 MAC address support. We support 12,000 MAC addresses. Alright. So you have a table here inside the switch, and the table will consist of the MAC. So you hash, let's say you hash the value mode 1000. Let's say you run hash mode 1000, you get 50. So here will be 0 until 9900. So on memory location 50, so this is the memory location. On memory location 50, you're going to put the MAC address 1 here. And this is the time. So probably you're going to put in the time, which time you have received. Let's say time is 100. Then you're going to put in the port, which port the packet was received. Let's say it's port 5. Then you put in the VLAN if there's any. If no, then put in 1. And there's also some other variables. Alright. So the whole entry here, it can be, depending on your design, it can be maybe 16 bytes. 10 to 16 bytes or more. Right. So this is a MAC address learning process. So we take the MAC address, you hash it, get the value, put it into the memory location. This is how the MAC address learning. Okay. So let's say now we're going to use the filtering and forwarding. So we go to MAC filtering and forwarding. So the bridge will get the frame and then it will hash the destination MAC address. Let's say this is MAC 2. Alright, and you get a value HMAC2. Alright. So then you take the HMAC2 and you modulus with 1000, and let's say you get 90. So you go to memory location 90. And you see the MAC address here. Alright, let's say it's Y2. So if Y2 is equals to HMAC2, if Y2 equals to MAC2, if Y2 equals to MAC2, then you will mesh. You have already found the MAC address, destination MAC address. Then you look at the time. See whether the time already expired. Alright, the time should be the time should be must be less than the entry time plus 300 seconds. All right, 300 seconds is the spanning tree protocol 5 minutes timer. Spanning tree protocol. Spanning tree protocol timer. All right. So if the time is valid, then you will see the port number. Okay. If the port number is the same, then you will filter the packet. If it's different, then what you do, you forward it to the destination port. All right. We are not discussing about the VLAN now, all right, because it will complicate the whole method. Okay. So you can see the searching and the learning and the forwarding is very straightforward. So they don't actually do search. All right. So in this case, you can do the search very quickly. All right. Even if you have 10,000 MAC address, you can do it very quickly. You just add more memory into it. Okay. Now let's look at some other issues. Collision. Collision. Let's say you have two MAC address where you have when you hash the MAC address 1, you get HMAC1. When you hash the MAC address 2, you get HMAC2. But then when you modulus HMAC1 modulus 1000, this is the table size, all right? Okay, or the number of MAC address equals to. Okay, so what happened? This is the first, this is the second. Let's say T is equals to, this one T equals to 100, T equals to 101. So we draw the table. First, the bridge learned the MAC address 1. So what happened? Which is 50, which is equals to 50. I go to on 350, 999. So we're going to put the MAC address 1 here. Alright, so this is the MAC. So when you hash the MAC address 2, you get the same hash. This is the time. You're going to put it to the next empty entry. Alright? So this, you call it a linear probing, where you study in algorithm courses. Alright? Algorithm design, whatever you want to name it. Alright? So you're going to put in MAC2, and I'm going to put it here. Alright? So suppose this is there's some entry here, you're going to put the next following entry until you find an empty entry, you just insert it there. Alright? So let's say, okay, so this is a collision, so we have solved the collision. Okay, let's say you now have a packet, you have a frame where the destination is equals to MAC2. So you're going to hash the MAC2, and later you're going to modulus 1000. You're going to get 50, which is here. Alright, 50. So then you go to location 50, which is here, and you see MAC1. does not match with your MAC address MAC2. So then, never mind, you go to the next entry, you see MAC2 is here. Alright, then you can see, you will check the timeout, whether it's timeout or not. If it's not timeout, then you check whether the port number. The port number maybe is 6 or 7, then you just forward or filter to the port. Alright, so in this case, this is how the entry is done. Alright. Okay, so what are the performance you are looking at, and what are the performance you're looking at, and what are the requirement you need? All right. Okay, so the performance, if the general rule of thumb is that you must maintain 50% full, alright? Or we can say the table must be less than 50% full, alright? Okay, or maximum 50%. Okay, so let's say if you have catalyst 3560, you have 12,000 MAC address. Support, your bridging table support 12,000 MAC addresses. So your table size will be 24,000. Alright, double. Okay, if you can maintain this double, then your search heap, you only need to search 3/2 time. Alright, where else your search miss will be 5/2 time. Alright. So if the hashing is even or uniform. Alright. So what do I say it means is like this, is that you have a MAC address. When you hash it, there's two possibilities. 0.5 times the chance is that you get a hit. Another 0.5 times you get a miss. Alright? So on average, you will hit. Alright? If you get a miss, you need to put it in another entry. So on average, you will need to have 1.5 times search time. Okay? Alright. If you get a miss, then you have to do this and repeat this. Therefore, you have 2.5 times search time. Alright? It's important that you must maintain the table size to have a maximum 50% full. Alright? Then you can achieve the performance required. Okay. Now the last thing, some of the complicated issues. Some of the complicated issue. Let's say you have 4 MAC address. You have 4 MAC address, and all of them matches the same entry. So you have like this. Let's say it's 20, 21, 22, 23. And here you have MAC 1, MAC 2, MAC 3, and MAC 4. Alright. So what happens where you have the hash of MAC 1 modulus 100, 1000 is equals to the hash of MAC 2 modulus 1000, which is equals to hash MAC 3 modulus 1000 equals to hash MAC 4 modular 1000, which is equals to 20. So all of them, when you hash it, it will go to this location. Since this location is full, you put it here, and put it here. Alright? So what happens if after some time you decided to delete this entry? Let's say you go to the iOS and you remove this MAC address. So this one will become empty. Alright, so when somebody now you want to do a hash, you want to find a destination, MAC3, right? So we're going to hash MAC3 and you get back modulus 1000, you get 20. Alright, so this 20 is here, defined, MAC3 is not here, but here is empty. So should he proceed with the search or not? Okay, so this is the problem, is the deletion in linear probing. Okay, so this problem has been solved. The details is implementation specific. You can add some other bits here, okay, or you can move the last entry to the empty entry and so on. All right, okay, all right. So this is implementation specific. I don't think you'll be keen to know about this, okay, but I just want to highlight to you these are some of the issues with linear probing in bridges and switches. Okay, if you have any question, feel free to email to me at ciscommu@gmail.com. Alright, so the purpose of this lecture is to relate to how does the studies in algorithm assist you in the switch and router implementation. Alright, so this is the very simple example. Alright, thank you.